Greetings and welcome to KYC. In this video, we'd like to discuss the process of cloud formation. Lively and incredibly fascinating. We may in this time-lapse clip observe them build and go away rather rapidly, although look at how our clouds are created. I enjoy considering how to create a cloud. The same way I may bake a cake, or I went to a favorite page in Cookies, the dated, worn-out recipe book, and there's I begin to notice various things. There are ingredients and in a recipe. The recipe is followed by instructions. How to combine, then bake the cake. In this instance, though, we won't bake a let's create a cloud out of a piece of cake. I shot this picture a few years ago to represent a large portion of what we must comprehend is cloud creation and cloud ingredients. I have a few items I want to attract attention to. Your focus will immediately notice that this Blues Creek Steam Station, a power facility, is a major coal-fired energy facility. You'll find it on the right side of that. Observe a few smokestacks, and I'd like to bring up the fact that there is smoke flowing from above and from the smokestack. That, of course, the cloud exists. So what is happening and where are our clouds? Components. Specifically, we require water vapor and specifically condensation nuclei. In this, I hope you can see how I mean. There must be a lot of water vapor in this area when we have a lake this size. Why do condensation nuclei exist? They are the particles in the air that are the atmosphere of Earth, such as ice salt microparticles. Smoke and dust include water vapor, although water vapor condenses into a pure gas. Condensation forms on surfaces, hence we must have tiny surfaces that the water can reach. As in this instance, smoke from the power plant offers the tiny surfaces that water vapor can condense on. Condensation is something that we observe, and when I was flying across the I saw this picture somewhere in the middle of the United States. There was a fire in the Midwest. Smoke was observed by the ground, and over the once more in this instance, smoke a cloud. The surface of the smoke particles is that would cause the water vapor to condense, and we have the necessary components to create a cloud. We must discuss the site where if you see a cloud, does it form properly? Typical cloud has a lovely flat surface. This is what we refer to as the bottom, a height or a level of condensation, a point in the atmosphere of the Earth where it is the same temperature as the dew point that we previously discussed. If dew point and temperature are same, the relative humidity must be 100. This is the percent location where water begins to condense of the air, which is obviously the location where clouds originate. Therefore, I'm not sure if you've ever had a chance to travel to the level of condensation, but it's a location with plenty of interest. Several years ago, when I reached we were ascending Mount Rainier. You could see quite a bit into the clouds. But then among the clouds, much below within a few meters, it was quite windy with peoples more than a few meters away is difficult to see since it was quiet and not white. Overhead and across snow, we were in a total whiteout. This is once more to the condensation level. Occasionally condensation levels are very high, though sometimes, but during a recent trip to Washington, D.C., the capital of our country, and captured this image of the Washington Monument, which is 555 feet tall, not able to view the pyramid shape. The head of the obelisk was in the clouds. So the condensation level was known to be 555 feet or less. On the here is another image of This is the condensation level from the hanging the mountains of North Carolina. The scene at Brock State Park was really spectacular. A day when there is less condensation, we once could see tens of miles away. Again, in a matter of meters, it changed into a total whiteout and a heavy fog cloud at a little higher altitude. Thus, if we know where we're going and what we're using, I must discuss the procedure if I'm going to preparing a cake or cookies requires me to my components for a cloud in the oven. Keep it, we don't want to bake in the oven. How do we proceed if we need to chill it? In regards to cooling our materials so as to make without a doubt a cloud, the most essential idea for creating a cloud is the concept of lift is all we really need to do. Raise it higher into the air and atmosphere. How is that most effectively done? Commonly, convective action is used. Cooling. Keep in mind that convection occurs when heated items that are less dense rise. As the air rises, it cools, and when condensation occurs, latent heat could be emitted as soon as water begins to condense. Because heat released could raise the convection for a while additionally keep in mind that the system needs additional energy. Even if it becomes colder the higher you go. As seen in this image, it accomplishes this. Something I recently captured while flying. You can see that the aircraft was in flight. 40,000 feet in the air. Outdoors it was 65 degrees below zero outside. Coupled with adiabatic cooling, convective temperature variations are a factor. As a result of adiabatic temperature change, as the air pressure decreases, the temperature could easily drop or rise. Going through an adiabatic temperature change, going outside and deflating your tires. Observe the valve's temperature. The motorbike, by the way, the tire begins at 74 degrees. Make sure you have plenty before you try this. Time to restart the fire, but you can observe after only a short period of removing air from the tire the temperature will drop significantly. In addition to convective cooling, an increase in temperature alters the upper wind. Currents might make these higher. Winds from above are to blame for the emergence and evaporation of clouds seen numerous times in this time-lapse film. Clouds will be visible above a mountain ridge. This is fairly understandable. Readily as damp air moves across to the Earth's surface and strikes it is pushed up and over the mountain. So frequently as in this mountain, wind was approaching in this image of Mount Rainier. As it approached the mountain from the west, when it reached the condensation, it arose level, a cloud developed, and the cloud on the leeward side of the vessel, evaporated mountain, is a different approach to cloud formation could take place nearer to the when warm air blows across a cold surface on the surface. We call this an advective. Advection cooling is the process of when we move the wet air and when a spring day with warm, humid air across a cloud developed over the leftover, chilly snow. Finally, another crucial procedure of one forms a cloud every 24 hours. Yes, when the sun sets. Cooling during night starts working when remove the source of the Earth's heat surface will cool, which frequently leads to cloud development at ground level akin to this early morning fog. Warning you, there are numerous varieties of clouds. Also, clouds can form at any time. Having the components and the required cooling procedure in the following in this video, we'll examine the various and cloud classifications. I appreciate you watching, and I'll be back. Awaiting your arrival in the upcoming video, and please don't forget to subscribe and hit the bell icon.